For a function f of xy, we suppose that the rate of change of f of xy in the x direction is 10. That means for every unit we move in this direction, the value of f of xy is going to change by 10 units. And that the rate of change in the y direction is 3, so that for every unit we move in the y direction, we have a change in the value of f of xy that's equal to 3. Furthermore, assume for the moment that the rate of change is constant, so that whatever distance we move in the x direction, this is going to apply. Whatever number of units we move in the y direction, this is going to apply, so that we change by 10 times whatever our x displacement is. That is, our value of f of xy changes by 10 times whatever our x displacement is, and our value of f changes by 3 times whatever our y displacement is. And that this applies throughout some region, so it applies to all points of the region that we've indicated here. Now we ask, what is the rate at which the value of f changes if we move in some other direction? Let's indicate that other direction by a unit vector u. Since we assume these rates to be constant throughout this region, we begin by simply asking, by how much does the value of f change if we move from some point x naught y naught to the point here at displacement u relative to x naught y naught. Now we can project our unit vector u onto the x and the y axes, leaving us displacements u sub x and u sub y. U sub x in the x direction, u sub y in the y direction. Well, if the rate of change remains constant, then the change in the value of the function f of xy, we have a change in the value of f of xy equal to 10 times u sub x, because f of xy changes at a rate of 10 units per unit of motion in this direction, per unit of displacement in this direction. Similarly, if we move u sub y units in the y direction, our change is going to be 3 u sub y. Now, the rate of change remains constant over all these, over this entire region, so that we have a change of 10 u sub x due to displacement from here to here, a change of 3 u sub y due to this displacement. Well, this displacement here is also a u sub y, so that we have a change of 3 u sub y as we go from this point to this point, so that starting at x naught y naught, our displacement u sub x gives us a change of 10 u sub x, and our displacement u sub y gives us a change of 3 u sub y, resulting in a net change due to the displacement u of 10 u sub x plus 3 u sub y. Now let's be a little more general. Instead of rate of change of 10 in the x direction, let's say we have a rate of change of f sub x in the x direction, rate of change f sub y in the y direction, so that change due to the motion, due to the displacement in the x direction is f sub x. The change due to the displacement in the y direction is f sub y. Let's simply replace all the 10s with f sub x's and all the 3s with f sub y's. And now we have a more general expression that indicates, that represents the change that would occur due to displacement u, again in a unit displacement in some direction represented by a unit vector u. So now the displacement due to the change in the value of f of xy due to the displacement u is f sub x u sub x plus f sub y u sub y, assuming still that the rate of change remains constant over this entire interval.